Hey, hi everybody. Oh, welcome to Dakota Test Prep question walkthrough. In this video, what are we going to do? It looks like we're going to do conductor sizing for a transformer. More than meets the eye. That was terrible. My production budget is exactly $0, so this is what you get. All right. What is the minimum size of copper R90 conductor in conduit required to supply a 65 kV three-phase dry type transformer with a 600 volt primary and a 120 208 volt secondary? Ooh, this one's juicy. I love it. I love it. Okay. Right off the bat, transformers are kind of like motors in that they're very, very, very finicky when it comes to the rules, making sure you are at the exact specific rule you need to be. For transformers, we got three kinds. We have our over 750 volts, we have under 750 volts, and our under 750 volts fall into two categories. We have dry type and other than dry type. Now, in my brain, just to make things easy, for some weird reason, I came up with wet. So when I see under 750, I say, is it dry or is it wet? For me, it just helps. As per usual, we're going to hit section 26, specifically for transformers. And depending on if it's over 750 or under 750 dry or wet, other than, we're going to go to the appropriate code for that specifically. All right, let's get rid of this. Erasing. Boom, there we go. Now, as with all C of Q questions, we always want to start with the same thing. What is it asking for? What do we have? What do we need? So in this specific question, what is it asking for? What is the minimum size of copper R90 conductor? Great. So it's specifically asking for conductor. When a question is asking for a conductor, we always say, which conductor? Because when it comes to certain installations, we have more than one conductor. Branch circuit supply, regular supply, feeder, tap. There's all sorts of different options. So in this specific case, it says required to supply. So we have a supply conductor in this case, which means right off the bat, that tells us it's going to be our primary. Because now we know we're looking specifically for conductor, specifically for supply, specifically for primary, any information that doesn't help us with that, we can ignore. So we look at this question and it mentions it's a 120 208 volt secondary. Do we care about that? Absolutely not. Because in this case, the secondary information has literally nothing to do with our primary supply conductor. The next one is, what do we have? Well, obviously we have our transformer info, which is fantastic. And what do we need? As with everything, we always need our ampies. We can't do anything without ampies. And in this case specifically, we need our rated primary current. So you know what? Let's figure that out. So we have 65 kV, which works out to 65,000. Uno, dos, tres. I'm learning Spanish. Divided by our primary voltage, which is 600 volts. If it was single phase, we'd stop, but it's not. So we're going to multiply by our fancy three-phase number, which is 1.732. If you feel like using the square root of 3, go for it. It's the same thing. Really all depends on what flavor of buttons you want to press on your calculator. So we end up with a rated primary current of 62.5 amperes. Are we done? Nope. Nope, we're not. Because what do we have to do? We have to find the multiplier. So we're going to go to the appropriate code and we're going to find our multiplier is 125%. So our rated primary current of 62.5 amperes times 125% gives us, drumroll please, 78.2 amperes. So this is the number we're going to work with. All right. What table are we going to use? Well, this one says copper in conduit. Well, that was easy. That's table 2. Once again, friendly reminder, the C of Q really likes to mess with you when it comes to this sort of thing. So if it mentions, or pardon me, if it doesn't mention copper or aluminum, we assume copper. If it doesn't mention free air or crammed into conduit or raceway, we always assume crammed into conduit or raceway. It's more than likely the C of Q is not going to mention things because they really want to know that you know what you're doing. So make sure you're on the same page with that one. So anyway, this one's easy, table 2. Now, which column? Are we going to use the 60-degree column? 75? 90? Who knows? Well, 4-006, that tricky guy comes into play, which says, if a termination temperature or equipment rating is not mentioned, if the amperes, our calculated amperes, which is this guy over here, is under 100 amps, or 100 amps or less, pardon me, we use the 60-degree column. If it's over 100 amps, we use the 75-degree column. Does this question mention termination temperature equipment? It doesn't. So we need to use this bad boy. We look at our amperes. Clearly it's under 100 amps. So even though we're using an R90 conductor, we have to use our 60-degree column in table 2. So we're going to head over here. Here's our table 2, our 60-degree column. We obviously go up here. We are not going to find amperes that are going to be exactly 78.2. That's craziness. So we're going to go up to the next size, which gives us a number 3. Or, for my Spanish speakers, that's a numero tres. Numero tres. My Spanish accent is bueno. Muy bueno. And look over here. We have a number 3 og. So, the minimum size of copper R90 conductor and conduit required to supply this transformer is a number 3. Now, specifically when it comes to the C of Q, again, pay attention to the fact that it's going to give you unnecessary information designed to confuse you. So when you do the, what is it asking for? What do I have? What do I need? Again, that is for you to be able to pick out the specific information you have and the specific information that you need and ignore everything else that's there designed to confuse you. And also another friendly reminder that the C of Q absolutely loves using 4-006 to mess with you. So that, my friends, is how we calculate conductor size for a transformer. And there's my little smiley face. Ta-da!